Welcome to Westel's Passive Components for Inquiring Minds. In this episode, we will discuss unequal power dividers. What are unequal power dividers and what are they used for? In another episode, we talked about power dividers. While we demonstrated their functionality, we did not mention that Wilkinson and reactive power dividers are categorized as equal power dividers. Equal power dividers distribute the input power equally among their outputs. Today, we will focus on unequal power dividers, which divide the input power unevenly between two outputs. There are two main types of unequal power dividers: directional couplers and tappers. Before we explore the similarities and differences between these two devices, let's first discuss their applications. In a distributed antenna system, DAS, there may be dozens of indoor antennas. Some of these antennas will be located close to the bidirectional amplifier, BDA, while others will be situated farther away. Typically, a DAS designer aims to create a balanced system so that all antennas receive approximately the same output power. How is this balance achieved when there are different power levels caused by varying distances from the BDA? A nearby antenna may experience minimal signal loss, while a distant antenna might suffer from long coaxial cable runs and multiple splitters. This is where an unequal power divider comes into play. When the BDA supplies power to a nearby antenna, the unequal power divider intentionally reduces the power sent to it, while directing the majority of the power to the antennas that are farther away. This added attenuation is calculated to compensate for the signal loss that occurs due to the coaxial cable and splitter losses on the far antenna. Design software can accurately calculate the necessary attenuation values to achieve a balanced system. Let's examine the similarities and differences between directional couplers and tappers. Both devices feature 3 ports. The 2 outer ports are typically referred to as the input and output ports, although they may not always be labeled as such. The middle port is known as the coupled port, which is associated with attenuation. The level of attenuation varies based on the specific model, with examples including 6, 8, 10, 13, 15, and 20 dB, among other values. When a signal travels between the input and output ports, different losses can be expected. There is no single answer to this, as the amount of attenuation at the coupled port impacts the signal loss between the input and output ports. For instance, a 6 dB directional coupler may experience around 1.8 dB of loss between the input and output ports, while a 20 dB model might only have 0.4 dB of loss. Tappers operate similarly, but generally exhibit slightly less loss compared to directional couplers. If the coupled port has an attenuation of 10 dB, what is it 10 dB down from? This highlights one key difference between directional couplers and tappers. In a directional coupler, the signal power entering the input port is the reference point, meaning the coupled port will be 10 dB lower than that. In contrast, in a tapper, the signal enters its input port and exits through its output port minus the loss through the tapper. The output power leaving the tapper is the reference, and the coupled port is 10 dB lower than this output. In summary, the coupled port's attenuation in a directional coupler is based on the input port's power level, while in a tapper, it is based on the output port's power level. One significant difference between a tapper and a directional coupler is their directionality. With a tapper, a signal can enter either the input or output port, and the coupled port will output a signal at its specified attenuation value. In contrast, in a directional coupler, the output port and the coupled port are theoretically not connected. This means that any signal entering the output port will not exit through the coupled port, and vice versa. In practice, some power may leak out, but this is usually 30 to 50 dB lower than the original signal level. Because of the directional coupler's directionality, it is very important to install it correctly. If the input port and the output port are reversed, the power out of the coupled port is 30 to 40 dB lower than what would be expected if the ports were not reversed. This is not a concern with tappers. When examining a distributed antenna system from an uplink perspective, consider a scenario where a first responder's handset or a cell phone transmits a signal that enters the coupled port of a directional coupler. In this case, the signal is directed solely back to the bidirectional amplifier. However, if we replace the directional coupler with a tapper, the signal's power will be split equally towards both the BDA and other antennas. While this may not significantly impact first responder radios, it can pose performance issues for cellular systems. In modern cellular networks, such as 3G, 4G, and 5G, each handset interferes with all the other handsets. Thus, if tappers are deployed, the uplink signal from any one handset could be transmitted through multiple antennas, leading to potential uplink issues. Whether this is a significant problem would depend on link budget calculations and the number of handsets in the building. But in summary, tappers can indeed cause performance issues with cellular signals. Directional couplers generally have better return loss ratings compared to tappers. On the other hand, tappers usually offer a wider passband than directional couplers. Directional couplers that can handle low frequencies, like VHF, tend to be larger than those designed primarily for higher frequencies. Conversely, tappers are physically smaller than directional couplers, particularly at lower frequencies. For instance, this directional coupler can support UHF 700 MHz and 800 MHz, while this tapper can support these bands along with VHF. It is essential to always check the passband of the specific make and model when designing and deploying these devices. Due to these characteristics, cellular providers typically prefer directional couplers, while public safety systems often favor tappers. Cost is also an important factor in making comparisons. While costs can vary, generally speaking, a tapper is about half the price of a directional coupler. You should now have a clearer understanding of the purpose of unequal power dividers and the distinctions between a directional coupler and a tapper.